Right now, all over the internet, videos are appearing with dramatic claims that the James Webb Space Telescope has finally turned toward Venus and discovered something shocking, terrifying, or even impossible. Depending on which thumbnail you clicked, the story can sound completely different. But there is a major problem with that claim. It didn't happen. And the reason why is actually much more fascinating than the fake story itself. It comes down to one of the most important design decisions behind the James Webb Space Telescope. Let's begin with what these videos are actually claiming. The usual story goes something like this. James Webb, the enormous infrared telescope responsible for some of the most spectacular images ever captured, supposedly pointed its massive golden mirror toward Venus and detected something nobody expected. The thumbnails usually show a blazing orange or red Venus covered in dramatic effects, while the narration promises a discovery so strange that scientists supposedly don't know how to explain it. It sounds exciting. But there is no credible evidence that James Webb has directly observed Venus. And there is a very good reason for that. To understand it, we first need to understand where Webb operates and how the telescope was designed. Unlike the Hubble Space Telescope, Webb does not orbit Earth in the traditional sense. Instead, it operates near a region of space called the second Lagrange point, or L2, roughly 1.5 million kilometers from Earth. That location was chosen for a very specific reason. Heat. James Webb is primarily an infrared telescope. It is designed to detect extremely faint infrared radiation coming from objects that can be billions of light years away. That includes ancient galaxies whose light has traveled across the universe for billions of years. But detecting such weak infrared signals requires the telescope itself to remain extraordinarily cold. If the telescope became too warm, its own heat would overwhelm the faint signals it was designed to detect. Imagine trying to see the tiny glow of a candle while standing next to a massive bonfire. The candle is still there, but the surrounding heat and light make it almost impossible to detect. Webb faces a similar problem, except on an astronomical scale. That is why the spacecraft carries an enormous 5-layer sunshield roughly the size of a tennis court. The shield blocks radiation from the Sun, Earth, and Moon, allowing Webb's telescope and instruments to remain on the protected, extremely cold side. This thermal design is one of the main reasons Webb can perform such sensitive infrared observations. And this is where Venus becomes a problem. Webb has strict limits on how far it can point away from its protected orientation. The telescope cannot simply turn in any direction it wants. Its field of regard is constrained by the position of the Sun and the need to keep the spacecraft's sensitive components protected. Venus is an inner planet. From Webb's position near L2, Venus remains relatively close to the Sun in the sky. That means Venus falls inside a region Webb cannot safely observe. To point Webb directly toward Venus, the spacecraft would have to rotate in a way that would expose its sensitive systems to sunlight and heat. That isn't something engineers can simply solve with a software update. The spacecraft was specifically designed around maintaining this thermal geometry. And this is also why Webb cannot directly observe Mercury or Earth. These planets are positioned too close to the Sun from Webb's vantage point. This isn't a temporary limitation. It isn't because scientists haven't gotten around to observing Venus. It is a fundamental consequence of how the spacecraft was designed. So what can Webb observe within our own solar system? Quite a lot. Webb has observed Mars, Jupiter, Saturn, Uranus, Neptune, asteroids, and distant objects beyond Neptune. Its observations of Jupiter have revealed details including Uranus and the planet's faint rings. It has examined Saturn and its ring system using infrared wavelengths. It has also observed Uranus and Neptune, revealing structures that are difficult or impossible to see using ordinary visible light observations. Beyond the planets, Webb can study much smaller and more distant objects, including bodies in the Kuiper belt. So Webb is absolutely capable of studying our solar system. It just has a specific region that it cannot safely point toward. And that distinction is important. Because while Webb cannot observe Venus directly, other spacecraft absolutely have. In fact, Venus has been one of the most extensively explored planets in our solar system. The Soviet Venera program achieved something remarkable decades ago. Several Venera spacecraft successfully landed on Venus and transmitted photographs and scientific measurements from the surface. Those missions had to survive temperatures around 460 degrees Celsius and atmospheric pressure roughly 90 times greater than Earth's surface pressure. Most of the landers survived only for a limited period before the extreme environment overwhelmed them. But during that short time, they transmitted some of the only photographs ever taken from the surface of another planet besides Earth. Those images revealed a strange rocky landscape beneath an incredibly dense atmosphere. More recently, NASA's Parker Solar Probe has made multiple close approaches to Venus as part of its journey toward the Sun. During one of those encounters, Parker's instruments captured unexpected infrared observations that allowed scientists to study portions of Venus that are normally hidden beneath its thick clouds. That was a real scientific result. No fake headline was necessary. Another major Venus mission was NASA's Magellan spacecraft. Magellan used radar instead of ordinary visible light cameras because Venus's thick clouds block our view of the surface. By bouncing radar signals off the planet and analyzing their reflections, Magellan created detailed maps of Venus's surface. The mission eventually mapped more than 90% of the planet. Those maps revealed enormous volcanoes, vast plains, mountains, fractures, and other geological structures that helped scientists understand Venus's complicated history. Japan's Akatsuki spacecraft also spent years studying Venus's atmosphere. Its instruments investigated the planet's enormous atmospheric circulation, cloud structures, temperatures, and unusual weather patterns. European Space Agency's Venus Express mission added another important chapter, studying the planet's atmosphere and surface environment from orbit. So the real story is not that Venus has never been observed. It has been observed extensively. The important point is that James Webb isn't the telescope doing that particular job. So where did the viral claim come from? There are several possibilities. One is simply the way online space content is produced. James Webb is one of the most recognizable names in modern astronomy. A video titled something like, "James Webb observes a distant Venus-like planet," may attract attention. But change that title to, "James Webb just saw something terrifying on Venus," and suddenly the potential for clicks becomes much greater. Another possibility is that real Webb observations are being mixed with misleading imagery. Webb can study exoplanets, including worlds that may have atmospheres or temperatures somewhat comparable to Venus. But an exoplanet orbiting another star is not the same thing as Venus in our own solar system. A thumbnail can show a familiar picture of Venus while the narration discusses an entirely different planet many light-years away. For a viewer who isn't checking the details, the difference can be easy to miss, and sometimes the explanation may be even simpler. Some videos are simply fabricated. A dramatic thumbnail, artificial imagery, serious narration, and a famous telescope name can create the appearance of a major scientific discovery even when no such discovery exists. This is why checking the source matters. Real discoveries usually leave a trail. There will often be a NASA announcement, an ESA release, a scientific paper, an observatory publication, or reporting from established science organizations. A major discovery involving James Webb would not normally exist only inside one anonymous video with no verifiable sources. And there is another reason this particular myth is so convincing. The real engineering behind Webb is already extraordinary. The telescope is positioned about 1.5 million kilometers from Earth and uses a massive multi-layer sunshield to maintain an extremely cold operating environment. One side of that shield can be exposed to intense sunlight while the telescope itself remains dramatically colder on the opposite side. That thermal separation is what allows Webb to detect incredibly faint infrared radiation. The sunshield itself is an engineering achievement. 5 extremely thin layers work together to reflect and radiate heat away from the telescope. During launch, the entire structure had to be folded into the rocket.